respond with certain thing. But if somebody calls you and a fax tone comes up and you can't understand, you can't talk, then what do? You hang up, you just hold the phone, what do? There is no protocol for that. Each one of us choose our own protocol typically to deal with those conditions that are limits or out of the boundary of the standards. What are the ways of the failure modes? How do you deal with redundancy? How do you deal with messages that are not supposed to be understood? Do you hang up? Does the process stop? Does the whole operation, the system come down? Or you ignore it, or you log it and let somebody else deal with it? You flag it? What do? Those elements need to be looked at, and certification does not deal with those elements. Vahid, I think this is for you to transition to here. Just a sec. Let me get this one. Where are you?
Well, what you're seeing before you is, I think Christoph covered several examples, and this is an actual implemented example of a system. This is a wide area remedial action scheme. What you're seeing on the far right, if you want to consider that this, of course, is a simplified version. These are devices that are streaming both serial link, and you can see the different speeds as well as through Ethernet. Here's your telemetry that's coming in. So there's been, on this side, of course, this is Ethernet structure, but during the implementation, as well as during the testing, again, these are all proof of concept, and then later on they transferred into production systems. This system now officially has been in service for 6 years. So on this side, you actually have a wire to the controllers as well as messaging. So just for timing purposes and trying to observe the performance. Some of these schemes are mission critical. So just going completely on one direction or the other, it's going to require a culture shock. So you may have to balance these out between a wire solution as well as a message. There are multiple controllers. So therefore, you bring a wire contacts to one device, but your messages to the other. And we did a lot of timing tests. And what you actually find out is that the messaging system, if I can call it, and I'm just talking about going data from here to the controller, is about, GOOSE messaging is about 1.5 millisecond faster than the contacts, the wires. And when I say that, a lot of people say, of course, but initially I don't think any of us had thought about it. I didn't. You want me to continue? I think most of us have tried to cover these for you throughout today, so I'll be really brief in the interest of time. But replacement of wires with communication, I think we have tried to demonstrate. I have some interesting ones. It says prevent mixing of DC circuits. If you're designing these for standards, if you have done quite a bit of these, you'll see how easily it is for people to crosswire on their designs as they go forward. So there are some things you have to be familiar. Earlier this afternoon, I mentioned that people that want to be the implementers, you really need to be very familiar with your existing, I underlined that word, existing standards. Because at the end of the day, that standard is really what your people are familiar with. And they're going to compare the new structure, the new architecture, the new design, and they're looking for methods to test it. So they're looking for the similar methods. Of course, it would be logic-based as opposed to wire-based. But you do need to establish isolation points. I don't know how many of you here are familiar with, if I use the word slip and O on a circuit breaker. Okay, so you got to be able to mimic that literally into your architecture, in your design. So it's once you do it, then people can take advantage of that. Again, in the interest of time, I won't read these, but one thing that if I can leave you with this one, I don't know again how many of you have experienced missing the last 2 feet of wire between your contact and your circuit breaker. Again, I don't know how many of you have seen that, but with a network-based system, you have a continuous monitoring and you'll know it. There's alarms. And the other method, the physical wire, and I'm not negating the wire versus, is that you'll know it the hard way. So, design requirement criterias. These are some of the requirements we had on the example that I just showed you. This throughput time is an overall throughput time. It's not, and you have to understand that this is a hierarchical structure, so there are multiple devices in the loop, and they have to add up the time. So message versus hardwire, again, local control wiring. And then on the there's been a lot of discussions regarding the process bus and well, how reliable it is, etc. So if the issue is, and I think Dan also asked the question regarding the packets and how often, how many, at some point you really need to balance redundancy versus the missing data. So I mean, you can obviously add bandwidth to the packets and to your network, but at one point you really need to balance this out. So if the concern is reliability, then redundancy may be the solution even for a process bus. This is actually the system. In this case, you can see the field devices are on the bottom here and the controllers are up here. This is a wide area system. Again, this is without naming the specifics. It is a mission critical function to part of the VCC. This shows you actually more details of it. Here's your device. There are triple redundant modular controllers. That means everything is triplicated. All the data has to go through a lot of voting process. Yes, there are hierarchical structures. In case something is not working, then you revert to 1 out of 2. But for now, just to give you the 25 millisecond time included all of the processes that have to get triplicated between the gateways as well as your, in this case, SMP gateways and the controllers as well as your field devices. So there's a lot of reliability built in, and of course then you have the redundancy aspects or disaster recovery. Some of the benefits that may or may not have been covered, I think Farnoosh touched on the life cycle, condition-based maintenance, okay, performance statistics, tools for clearance analysis and tracking, database historians, okay, flexibility in engineering. So there's a number of things that really come out from a end user perspective, also in terms of the benefits. I think we touched on this quite a bit, so I won't take your time, but it is something that I also had at the very beginning of this, as far as the implementation. This is a practical example. Someone was asking earlier in the presentations how many schemes are in the North America. This is embedded. This is a control. This is an interlocking scheme. If this line, for example, has reclosing, and the reclosing can be switched between the breakers, if operational requirements are the breaker that's tied to the bus is the one that's going to be assigned to do the rapid reclosing, this breaker would automatically have to be assigned to do automatics or parallel, etc. So all of those interlocking can be done. There's interlocking with the bus differential. So if you do have a bus differential, then again, there's a lot of interlocking that takes place on just one bay between the breakers as well as between the breakers on the bus. So there are papers on this. We've published a couple of papers at Georgia Tech. I think it was 2006, 2007. Sakis should remember that, right? It's published, but you can see a lot of detailed interlocking examples. What's really needed? You don't need to read this as much. This is how I ended up doing it originally. But the message really is R for remote, meaning message, and you will see some places I have remote output And so these are all messaging, if you want to call it, I call it messaging rather than fancy words of the GGIOs or the GOOSE messaging, because my people work differently. So the key thing is tools. The more tools you have, the easier the life would be in implementation. And I think that that's really the key thing that is required for you. So in this case, I built a lot of tools to make it easier for. So there's a number of, here you can see all kinds of messaging, breaker failure to DTT. Okay, so you can see this is a physical input because it says remote input. No, it's messaging. Sorry, this is input versus output. So you can see remote block close. So the tools, if the tools are there, it would make it easier. Adequate training of engineers and practitioners, adoption to existing substation automation. So here's some of the examples I showed you are protection and automatics or controls. Automation, of course, is another area where DNP is heavily used as opposed to, with the 61850. We talked quite a bit about these, but tools is really a key to rolling out. Examples of implementation, when you want to isolate, one of the challenges I've had is, and particularly that's why I was mentioning you want to be very familiar with your system, is people are looking for, when they want to isolate, they have a test switch that they're opening, or they can lift a wire, if I can use that terminology. Christoph mentioned this test method in his presentation where you broadcast and it basically creates a path for testing and it isolates the other path. Of course, some of these, but yeah, if they're looking for physical isolation points on a message, so you have to sort of build that into your architecture. It's not that difficult. It may be as simple as stopping a message, but you really need to make sure those are intact. I think that in the interest of time, I just go to the summary, and that's why I was saying here, balancing wire versus messaging. You really need to know your application to do this, but you do have several live examples of this in place, whether it's in North America or in the PG&E projects. What we've done is a lot of these are applied into what we call the modular building. Some of you are familiar with the whole idea is that you can drop in a control building as opposed to going inside your existing control and replacing one panel at a time. There's roughly about 80 substations in service. So if you wanted to know some examples, there's a number of them. That's just one company. I know AEP is doing quite a bit of work on this. I know a number of other North American power companies that have been doing a number of project works with IEC 61850 and GOOSE messaging. I think that this would maybe a good point if you want to touch on the interoperability.
Thanks, Fahid. I'll just go through some of the interoperability tests, mostly based on the synchrophaser system proof of concept facility at PG&E. I did mention to you about 22 minutes ago, keep in mind that diagram showing PMUs, PDCs, super PDCs connected to each other. Any one of those have to work with each other. So when we come to interoperability testing for synchrophasers in particular, we look at PMUs connected to substation PDCs. They may communicate or may be able to communicate in more than one protocol. And within the whole system, we may actually have some communicating in one protocol, let's say C37118 2005 with some form of UDP communication, and then as well as 61850-90-5. So there is a lot of tests to be done to make sure they all work together fine in both or even more modes than may be possible that they are required for the project. Substation PDCs to super PDCs, sometimes PMU sending data directly to super PDCs, and data going in the other direction too. Stream data usually goes from PMU to PDC and upwards, depending on which direction you call up. But control data, configuration data, start, stop, streaming, elements of that, one-time communication status may actually be communicated the other way. A super PDC may send, as opposed to receive data, may send a start streaming message to a PMU, for example. Comparisons between various standards and also connections to various other elements of the system, not just PMU streaming, timing signals, whether it's IEEE 1588 version 2 with C37-238 power profile, or whether it's IRIG-B, or both in this case in the project. Many devices are capable of doing both. They're also required to do time quality tagging information and compare the two when they are provided with both time information. So there's a number of those tests. And the whole test setup for interoperability done is, of course, in layers, meaning first you look at, can these devices communicate, receive data and parse it, separate them, or what they receive they just totally don't comprehend depending on, their interpretation of the protocol. Once they can do that, then you can look at, okay, is the data that is received and parsed correctly understood? Is it, for example, you assume it's a 16-bit integer, whereas this was a 32-bit floating type data, or whether it was a polar coordinate versus rectangular coordinate. Do we understand it correctly? And then if the data received is corrupted, what happens? You just dump it out. Does the PDC send it up regardless of the understanding of it? Does it flag it? Does it stop functioning? What are the things that it does? So there is a lot of interoperability tests on the system in that front. One of the examples, 5 minutes? Good. I won't go through much details. A lot of these you have seen either, let's say there was some presentation in the last NASPI meeting, particularly on the interoperability demo. If you go to the NASPI site or the PSTT site, you will see a lot of these slides. Of course, what's in here will be available on the NASPI website too. But looking at various types of data, PNM class being sent, and what happens with different switches, different routers, different protocols on the way, multiple PMU sending data through different protocols, in this case C37-118, as well as 90-5 going to Super PDC, comparison of unicast and multicast. Again, how do they compare? What are the issues? Bandwidth requirements, latencies. Maybe that's the summary in terms of the interoperability test. For what we have found in this particular project, having a very collaborative testing environment is very, very, very significant element. We have had many different manufacturers contributing there. One of the things you find out in sort of interoperability tests, unless the technology is super mature and is long into it, is you find issues and you need a group that is willing to solve those issues, work on implementation agreements, work on details, resolve those, change those, and retest them. So you go through many repeats, if you like, or layers of testing. At each level, you sort of peel different layers of onion and you get to the core of it. Of course, as with each layer peeling, you have some tears to shed too. And sometimes you repeat that. Comparisons between unicast and multicast implementation, and looking particularly at security features. Security features are required, but at the same time, you got to keep in mind they could make the testing very complicated. Same things that block you from getting into some data path, may not allow you to sniff through the data path, be able to measure the latency. It's always a compromise. How much are you blocking other people within your team from getting to that information? Ultimately, when everything is done, you want everything to be nice and secure end to end, but through the process of implementation, you got to have all the right tools and right elements to be able to deal with that. Maybe, again, Vahid emphasized this already, and I think we are trying to emphasize it with repeat of words again and again. Having tools for network-based communication, network-based data, and standard-based data communication, it's really essential. It is important for the actual maintenance of the system. It's important for the testing. If every time you want to configure a PDC or a PMU, it takes 2 hours, your repeat testing, changing, every layer of that onion takes a long time. Okay, having those tools is very, very critical. You can do a lot of automation, or even if the person is involved, it really helps that. So I can't emphasize anymore having those tools in place. It really helps with interoperability. Testing. Please do take a look at PSTT and NASPI website. There's a lot more details there, and also previous presentations. We want to have time here, I think, for some questions, so we'll close it here. Any clarifying questions first?
I'm going to have Raul present a couple of slides.
Yeah.
Okay, just thought give you a brief update on what's happening with the standard. Yeah. Here we go. Just to better understand how the standard is working. One of the things that obviously the 90-5 was derived from the C37-118 working groups when they started the second phase of that and decided that to separate the protocol from the synchrophaser calculation part of the standard, and agreed that a higher level standard is needed, and that's kind of what started building on the 90-5 effort. But you'll see in that thing it says TR, and what that TR means is technical report. And what it is, all the 90-X series standards are technical reports from an IEC perspective. And this allows the working groups to get the documents out into the public and into the hands of implementers quickly, rather than having to wait for the next 5 years revision cycle on 61850. And so the plan then is after the TR is published, the next revision cycle on the standards occurs, we take the stuff out of those TRs and put them into the standard. So one of the things that's happening right now is with 61850 and 90-5 is parts of these things come out of that standard or out of that technical report and get put into the standards. The use cases, for instance, are going to come out of that and be put into an IEEE recommended practice white paper. I guess Mark just took off. I can't remember the exact title of the document, but the IEEE PSRC is working on a document for best practices and a white paper, and that the use cases will be moved into there. 90-5 includes enhancements for the substation configuration language from Part 6 of 61850. So that includes the communication configuration information associated with running over the IP multicast profile. So some of that information needs to be incorporated into Part 6 in the next revision cycle. The security enhancements for the 90-5 session protocol that uses the symmetric key exchange, as well as the use of GDOI to initialize and get those keys. That information is going to be put into a new part, an update to the IEC 62351 standard, which is the communication standard for 61850. That's Part 6. The current Part 6 uses PKI, public key infrastructure. It's getting migrated over to the symmetric key exchange of the 90-5 stuff. And as a matter of fact, the working group just met last week, and they've adopted this, and this will be included in a revision to Part 6, and it's being worked on right now. The same thing with the multi-key distribution. In Part 9 of 62351, this is key management. Obviously, one of the key important issues, I should not use the word key all the time, one of the important issues in addressing secure communications is how do you deal with all the keys from the devices? And I think that with the adoption of GDOI, the symmetric key exchange within the session protocols, we're starting to get to the point where secure communications on a larger scale is going to become achievable. We have some good solutions and some ways to accommodate that. So the 90-5 GDOI profile is going to get put into the Part 9 standard for key distribution. And the additional profiles from 90-5 are going to put into the profile work for 8.1 and 9.2. So there'll be the IP multicast profiles will be put back into the 61850 standards, and as well as the C37-118, the 61850 migration. This is the one of the documents being worked on by IEEE PSRC. So a lot of the use cases and other things that are in that technical report will get put in. Yep, so moving forward, that's basically, these are all going to be tagged as addendums. The target dates here, let me just skip here to the end here, what the meeting schedules are. They just met in Detroit last week. We have some meetings coming up in January. I think the idea here is that the Part 6, the IEC 62351 standard, should be in a committee draft for vote in probably by mid next year. So the work is being done right now. Hopefully we might have an IS done in late 2013. So that progress is being made and it's real, and there's a variety of meetings taking place. If you're not on these things and you're intensely interested and want to contribute, I think most of the standards guys love it when users participate, so consider. Thank you.
Okay, thank you. Let's give a hand to all the presenters. Okay, so now we'll have a 15-minute panel, and you can ask
Yeah, I know. It's up there.
Individual panelists recognize the whole panel, and they can select who's going to answer. And please introduce yourself.
Hello, I'm Alan Goldstein. I'm going to be getting started with NISP next week. Demir actually encouraged me to mention this. It's something that you guys can touch on, but this is really a discussion that we need to have, a long discussion that we need to have about the considerations of where 90-5 should be used and where it should not be used. I mean, it's going to be adding some latency. There's a cost to vendors in implementing. We'd like to, try to understand what the adoption timing is going to be. Let me give an example. For example, should 90-5 be used between PMUs and substation PDCs? Should it be used in protection applications? Should it be used, or if it's used, will it preclude possibly some applications that require very low latency? So, will PMUs, considering the vendors and vendors making plans for their development, will PMUs need to do both C37.118.2 and 90-5? So this is a discussion that we really need to have over the next couple of meetings. It's a wider discussion. I invite anybody who wants to respond to that now, to maybe add some of your thoughts to that.
Well, there's a lot. We'll talk for a couple hours on that, but yeah, I think it'll be clear that in fact, obviously vendors are going to have to support both for some time. That's true of all protocols. As you migrate, you transition to them, you're going to have to support both of them. Just as the way if you're migrating to 61850 from 6870-5101, you're not going to just throw that away. So yeah, I think these things have to coexist and can coexist.
I was just going to agree with what Ralph was saying. I think, I mean, I'm coming from the substation automation area where there's been DNP now 1815 and 61850, and the rule is any device sold today in that realm needs to support at least those two, if not more. Because every kind of scenario element that you've mentioned and 100 more are the real world, and we can't even anticipate all of the various scenarios that the end user is going to face as he migrates forward. So the only safe way is that every gateway and every end device supports all the various options. One thing I would emphasize, though, and that we've learned on the very closely related substation automation area, is we need a standard way, an agreement on how we're going to map. So that a gateway and a PDC and a PMU, when we do this mapping, everybody's agreed how we're going to map, so we don't further complicate our lives on the interoperability side. You know, you've heard some lessons learned here and so on, and we want to continue to progress from an interoperability perspective and interchangeability.